Rational application problems. Application problems are important, or word problems if you will, because this is where math is actually used outside of math class. TI-89 graphing calculators and most math software can pretty much solve any problem that you're working on, solve any equation and so forth. You have to be able to do what a calculator cannot do, which is problem solve. Assess a situation, figure out what the problem actually is and what you have to work with, what you know about the problem. Come up with a plan in order to solve it. Carry out the plan, but don't forget step number 4 here, make sure your answer actually makes sense. Make sure it seems reasonable. Make sure you answered every single part of the problem, and of course always include the proper units. Now application problems are a higher order of learning, applying what you know instead of just memorizing. And most application problems are solved a little bit different from one another. Now some of them can be put in the categories as we're going to go through here, where they are solved somewhat similar to one another, but not all of them. Some of them are just general application problems. So let's look at example 1, which is just kind of a general application problem. So read the problem, you may need to read it a couple of times, understand what's going on. Overall concept here, we have two unknown numbers. So we're going to put these two unknown numbers in terms of our variable x. Well, we need a starting point, so that would just be the first unknown number. What it tells us is that the other is 9 larger, which we'll represent as x plus 9. Continue reading, converting the mathematical words into terms or expressions. The reciprocal of the smaller number, so x is the smaller number, its reciprocal, 1 over x, is added to 4 times the reciprocal of the larger number, so 4 times 1 over x plus 9 is going to be equal to 2/3, which if we neaten up a little bit, we'll see it's certainly a rational equation, which we know how to solve. The LCD is simply going to be 3x times x plus 9. So multiply the equation by it. The first term, the x's cancel out, leaving us 3 times x plus 9. Plus the second term, the x plus 9's cancel out, leaving us 3x times 4, 12x, is equal to the third term, the 3's cancel out, leaving us 2x times x plus 9. Simplify. We see that exponent of 2, so we know it is a quadratic equation. Get all your terms on one side of the equation, setting the equation equal to 0. And then of course we solve these by factoring. Which gives us 2 possible solutions, negative 9/2 and 3. Now we're asked to find 2 numbers in this problem, but these are just 2 possible answers for x. So it's always important to understand what we set x equal to. X was just the first number. And sometimes it is possible to have 2 realistic or 2 possible values for it, but in this case, since it specifies in the problem that they are positive numbers, of course we cannot have the negative 9/2, which means the first number is 3, and if the other number is 9 more, it must be equal to 12. Now we can certainly check ourselves, make sure it checks out. It says the reciprocal of the smaller, which would be 1/3 in this case, plus 4 times the reciprocal of the larger, plus 4 12s, would be equal to 2/3, and it is. So everything checks out the way it should, so we're confident we have this problem correct. One type of application problem associated with rational equations, one of the more common ones, is what's referred to as an hourly job problem. If you read the problem, understand what's going on here. I think everybody can probably relate it to past experiences. If you ever had to do a group project or anything, not everybody works at the same rate. In this case, we have Martha, who can do a job, in this case rake the leaves. Takes her 6 hours. Her brother, a little bit slower, takes him 7 hours. So how long will it take them to work together? Well, a little bit of common sense. If they're working together, we know it's going to be less than 6, maybe around 2, 3, 4 hours. But what we're asked to find then, of course, is the total amount of time, which we'll set equal to x, the unknown value. So what we're going to do in order to come up with our equation is we're going to break this down into 1 hour. What part of the job will be completed at the end of 1 hour? So if they're working together, Martha will have 1/6 of the job completed at the end of 1 hour. Her brother will have 1/7 of the job completed at the end of 1 hour. So if they're working together, we're going to add those two amounts together, which is going to be equal to 1 over x, the part of the total job which will be completed at the end of 1 hour. So as you can see, we have a rational equation, LCD, 42x, so multiply through by it. Gives us 7x plus 6x equal to 42. So 13x is equal to 42. X works out to be 42 over 13, and of course our unit is hours. Which, just read the problem, see how it wants the answer entered in, whether it's as a simplified fraction, 42 over 13, or if it has to change it to a decimal, which would be approximately 3.23 hours. Basically exactly what we anticipated. Another type of application problem is a distance problem or motion problem. Something moving at this particular speed for a certain amount of time is going to travel a certain distance. In order to do this problem, you have to know the distance formula. Distance is equal to rate times time. So if you read the problem, this person is kayaking, but there's actually two different parts of the trip. So in part A, we're going to have to use this formula twice. So the first part is when she's going downstream. The second part is when she's turning around and going back upstream. So fill in the information we know. First of all, we know she paddles 5 miles downstream, then turns around and paddles 6 miles upstream. Her rate, well, when you're in a river or a stream, whatever the case may be, the speed that you can paddle in still water, which is going to be x, what we're solving for in part A, is going to be affected by the current. The current is either going to make you go faster if you're going downstream, or it's going to slow you down if you're going upstream. So the first part of the trip, when she's going downstream, that current is making her go faster, coming up behind her and basically pushing her along. So it's going to be x, the speed that she can paddle in still water, plus 1. When she's going back upstream, now it's slowing her down. It's a drag. X, the speed that she can paddle in still water, minus 1. Now these two times will probably be different. We don't know what they are, so we'll call one time 2. But we know these two times must add up to a total of 3 hours. So we have our equation here. Just take each one and solve for the time. T1 is going to be equal to 5 over x plus 1. T2 is going to be equal to 6 over x minus 1. So substitute these values in. These two times must add up to 3, so 5 over x plus 1 plus 6 over x minus 1 must be equal to 3. As we can see, we have an equation, more specifically a rational equation. So our LCD, x plus 1, x minus 1 multiplied through 5 times x minus 1 times 6 times x plus 1 is equal to 3 times x plus 1 times x minus 1. Simplify. And solve the equation. Like most quadratics, we come up with two solutions, but since it's an application problem, we have to make sure they both seem reasonable. Once again, make sure we have a clear understanding what x stands for. X in the problem is what we set the speed that she paddles in still water to. So do both of these seem reasonable? No. Can't speed a negative speed, so x is equal to 4, more specifically 4 miles per hour. Part B is she went 4 miles downstream and then 6 miles upstream. Now she's a mile upstream of her original starting point. How long will it take her in minutes to get back to her original starting point? So just using the little distance formula again, distance is equal to rate times time. She only has to go a mile. When she's going downstream, it's her speed that she can paddle in still water plus 1. So she can paddle 5 miles per hour times t. Solve for t. T is equal to 1/5 hours. But the problem asks for minutes, which would be 12 minutes. Extra practice problem number 1. Read the problem, understand what's going on. It's just a general application problem. Overall concept, there's two unknown numbers. So we'll set it up. First unknown number, second the x represent the first. It says the other is 6 less, so x minus 6. 2 times the reciprocal of the smaller number. So the smaller number is x minus 6, so reciprocal 1 over x minus 6 is added to 5 times the reciprocal of the larger, so 5 times 1 over x, and the sum is simply equal to 1. Simplify or neaten that up a little bit. 2 over x minus 6 plus 5 over x is equal to 1. Obviously a rational equation. The LCD, x times x minus 6, and multiply the equation by it. The first term, the x minus 6 is cancel out, leaving us 2 times x, or 2x. Plus the second term, the x is canceled out, leaving us 5 times x minus 6 is equal to x times x minus 6. Solve the remaining equation. 2x plus 5x minus 30 is equal to x squared minus 6x, another quadratic equation, set it equal to 0. X squared minus 13x plus 30 factors into x minus 3, x minus 10, which gives us two values for x. X is equal to 3, x is equal to 10. Well, we found two numbers, but once again, they're just two possible values for the first number. So it says the first number has to be a positive number, and these both are. But the second number is 6 less, also has to be a positive number. So if x is equal to 3, you subtract 6 from it, it gives us a negative 3. So we cannot have that possible answer, and therefore x is simply equal to 10, which makes the other number 6 less 4. And we can check ourselves. 2 times the reciprocal of the smaller number, so 2 over 4, plus 5 times the reciprocal of the larger, 5 over 10, is equal to 1, which certainly checks out. 1/2 plus 1/2 is equal to 1. Example 2, read the problem, understand what's going on. A small pipe takes 3 times longer to fill a pipe than a larger. So we have a small pipe, we have a large pipe. If we let x represent the time the time it takes the large pipe to fill the tank, the small pipe, 3 times larger then, would be 3x. So it says if they're used at the same time, x plus 3x, it'll take 12 minutes. So therefore, how long will it take the small pipe alone? So solve for x. X is equal to 3, which is the time it takes for the large pipe, 3 minutes. It's asking for the smaller, so the smaller pipe would take 3 times that, 9 minutes. Number 3, read the problem, understand what's going on. Distance problem, so distance is equal to rate times time. 2 parts of the trip again. First part, and then the second part. So what we know is, first of all, the first part of the trip, she's ran for 3 miles. The second part ran for 4 miles. We don't know how long she was running at 3 miles for the first 3 miles, but for the second 4 miles it says she increased her rate by 2 miles per hour, so x plus 2, which these times are probably going to be different, so time 1, time 2, where we know these 2 times must add up to a total of 1 hour, how long she was running. So solve for each time. Time 1 is going to be equal to 3 over x. Time 2 is going to be equal to 4 over x plus 2. Add these 2 times together. 3 over x plus 4 over x plus 2 will equal the total amount of time she was running for 1 hour. Solve this equation. Obviously the LCD, x times x plus 2, multiply through, 3 times x plus 2 plus 4, x is equal to x times x plus 2. When you solve this equation, simplify, it works out to be a quadratic, x squared minus 5x minus 6, which factors into x minus 6, x plus 1, which gives us 2 solutions, 6 and negative 1. 2 possible solutions for x, which once again was the rate she was running for the first 3 hours. Well, rate can't be a negative number, so x is simply equal to 6 miles per hour. So for the second part of the trip, the remaining 4 hours she was running at 8 miles per hour. which that's what the problem was asking for. So the final correct answer, 8 miles per hour. Example 4, another hourly rate problem. In this case, 3 people are working together. This first person, Dusty, can do the job by himself in 5 hours. The second guy, Felipe, takes him 6 hours, and the slowest one, Grady, takes him 9 hours. So if they're all working together, we know it's definitely going to take them less than 5 hours, but we'll set that equal to x. So break it down into 1 hour. At the end of 1 hour, Dusty will have 1/5 of the job completed. Felipe, 1/6, and Grady, 1/9. They all work together. They have then 1x of the job completed. Rational equation, LCD, 90x. Solve the equation. X is equal to 90 over 43. The unit, once again, is hours.